Hello science fans, welcome to another exciting journey into the world of technology. Today we are diving into the amazing world inside your computers, where every piece of data has a story to tell. We call the smallest piece of this information a bit. It's the fundamental unit of data. Think of a bit like a light switch. It can be either on or off, just like a switch. It can be on or off. This simple concept is the foundation of all digital data. In computer language, on is represented by a 1 and off is represented by a 0. So a bit is either a 0 or a 1. It's that simple, yet incredibly powerful. One bit by itself cannot hold much information. It's like a single letter in a book. When we group 8 bits together, we get a byte. This byte can hold more complex information. This byte can represent a letter like A or B, a number like 5 or 9, or a small symbol like a punctuation mark. Bytes are the workhorses of data storage. They are essential for storing and processing information. They are a fundamental building block for everything your computer does. Bits are the atoms and bytes are like the molecules of the digital world. Together, they create the digital universe. A megabyte is roughly 1,000,000 bytes. Imagine how many bits that is. That is a lot of bits working together to store your data. Your computer's memory and storage are all measured in bytes. The more bytes you have, the more data you can store. The more bytes you have, the more information you can store. It's like having a bigger bookshelf for your digital library. Understanding bits and bytes helps us understand how computers handle all the cool stuff we use them for. From games to emails, it's all bits and bytes. Every picture, email, and website boils down to these zeros and ones. They are the building blocks of our digital lives. So, next time your computer does something amazing, remember the humble bits and bytes working tirelessly behind the scenes. Alright, we have talked about bits being zeros or ones. These bits are the smallest unit of data in computing. This system of using just 2 digits is called the binary system. It's fundamental to how computers operate. The prefix bi means 2, like a bicycle has 2 wheels. Similarly, binary has 2 digits, so binary is a base 2 number system. This means it only uses 2 symbols, 0 and 1. For computers, binary is perfect because they are built from electronic circuits. These circuits are the backbone of all computer operations. These circuits understand 2 states, electricity flowing on or 1. This is a fundamental concept in electronics, or not flowing off or 0. This binary state is crucial for processing data. Using binary, computers can represent all sorts of information. From text to images, everything can be encoded in binary. A byte, which is 8 bits, can represent a character. This is a basic building block of data storage. For example, the letter A might be represented in binary as 0, 1, 0, 0, 0, 0, 0, 1. Each character has its own unique binary code. Each position in a binary number has a value, just like in our regular number system, but the values are based on powers of 2. But instead of powers of 10, binary uses powers of 2. This is why it's called a base 2 system. This binary system is the absolute bedrock of all computing. Without it, modern computers wouldn't exist. Programmers write code in languages that look more like English, but compilers translate that code into binary instructions. This translation is essential for the computer to understand and execute commands. Understanding binary is like learning the alphabet before you learn to read. It's the foundation upon which all computer knowledge is built. Now let's talk about the number system we humans use all the time. It is called the decimal system. The prefix DC means 10, like a decade is 10 years. This means it uses 10 unique digits to represent all numbers, 0 to 9. In the decimal system, the position of a digit determines its value. While computers thrive on binary, humans find decimal much more intuitive for everyday calculations. We have explored binary, base 2 for computers and decimal, base 10 for us humans. But there is another important number system in the world of computing, hexadecimal, or hex for short. Hexadecimal is a base 16 system using digits 0 to 9 and letters A to F. The main reason hexadecimal is so useful in computing is that it provides a very convenient way to represent binary numbers. Each hexadecimal digit can represent exactly 4 binary bits, a nibble. For instance, the binary number 1101 can be represented by the hexadecimal digit D. Hexadecimal acts as a helpful bridge, more compact and easier for humans to read than long strings of binary code. It is commonly used to represent things like memory addresses and colors on web pages. Understanding these different number systems, binary, decimal, and hexadecimal, is great. Each system has its own unique way of representing numbers, which can be very useful in different scenarios. But what is even more useful is knowing how to convert numbers between them. This skill can be incredibly handy in fields like computer science and digital electronics. Let's start with converting binary to decimal. This is a fundamental skill that can help you understand how computers process data. It is all about place values. Each digit in a binary number has a specific value based on its position. In binary, each position represents a power of 2. This makes it easy to convert binary numbers to decimal. For example, binary 1011 is decimal 11. You simply add the values of the positions that have a 1. Now, how about converting from decimal to binary? This process is slightly different, but equally important. This involves a bit of division. You repeatedly divide the decimal number by 2 and keep track of the remainders. Decimal 13 is 1101 in binary. You can see how the remainders form the binary number. Converting between binary and hexadecimal is even more direct. This is because hexadecimal is a base 16 system. Since one hexadecimal digit represents 4 binary bits, a nibble, you can convert by grouping. This makes the process straightforward. For example, binary 11010101 becomes D5 in hexadecimal. You just group the binary digits into sets of 4. To go from hexadecimal to binary, you do the reverse. Break the hexadecimal digits into binary nibbles. For example, hexa 9 would be 10101001 in binary. This method ensures accuracy and speed. These conversion skills are like being able to translate between different languages. They open up new ways to understand and manipulate data. They allow you to see the same information represented in different ways, each useful in its own context. Mastering these conversions can greatly enhance your problem-solving skills. You might be thinking, why do I need to know about bits, bytes, and these number systems? For programmers, knowing about binary and hexadecimal helps in understanding how data is stored in memory. Network engineers deal with IP addresses and MAC addresses, which are often written in binary or hexadecimal. Understanding these foundational concepts can significantly aid in debugging. It is practical, powerful knowledge for anyone serious about the digital world. Wow, what a journey we have been on. We started with the very smallest pieces of information, bits. A bit is just a 0 or a 1, an off or an on. When you group 8 of these bits together, you get a byte. These bits and bytes are the invisible building blocks of every digital file, every program, and every piece of information your computer processes. We then explored the computer's native language binary. This base 2 system, using only zeros and ones, perfectly matches the on-off nature of electronic circuits inside our computers. We also looked at our familiar decimal system, base 10, which we use every day. Then we introduced hexadecimal, or base 16. This system acts as a fantastic shorthand for binary. Understanding bits, bytes, and these number systems is like having the key to unlock the secrets of how computers work.